But today is 6th December 2023 and we are solving deformation questions. And in the last class, we have solved question number 3 and 4 completely. But the last part of the question we did not solve, and it is a very difficult question. And not only difficult question, but I am interested to explain this question a different way. And what is a different way? Let me explain. The topic is in Young modulus equation, you know that Young modulus is force per unit area and extension per unit length. It is Young modulus equation. It is Young modulus equation. Acha beta, in this Young modulus equation, if you are given force value, length value, area, and any other quantity, then you can calculate unknown from the equation. But sometime this method is not applicable. Just like in this question, if you read the whole question, no numerical value is given. No numerical value is given. You are given a graph, and by using given conditions, we have to plot a new graph, and no numerical value is given. So, beta, when no numerical value is given, then I use a method which I call same quantities को kato. Kato means cancel out. Okay. But I call this method same ko kato. So when you are not given numerical values and now you have to solve this question by same ko kato. So what is the method of same ko kato? So I'm going to explain. Young modulus, it is equals to force per unit area, extension per unit length. Okay. And the question is, you are given a rod in the last class and you are given a graph. Now today the same rod is replaced by a new rod. Same rod which we have drawn graph, balki we were given a graph, and today it is replaced by a new rod, and this new rod has same original length. When you are given same original length, it means length remains same. And as I said same ko kato, so I am cancelling length. Why? Because it is question same original length. So I am cutting same length. Okay. And now read more question. Sketch the variation of force of the length for new rod from 0 Newton to 90 kilonewton. Actually, in the last class, force were 0 Newton to 90 Newton. And for this new rod, again force value remains 0 to 90 kilonewton. It means force will also remain same. So same ko kato. So I have cut force as well. Okay. And now if I ask you to make small e as a subject, why I'm going to explain. Then E is equals to 1 upon A into E. And in the last class, we have noted 0 to 90 kilonewton. हाँ beta, 0 to 90 kilonewton. What is compression in the rod? Sir, original length 150, final length 148. So the compression of rod is 2 millimeter. It is compression. It is compression. And the compression value is 2 millimeter. And it is for old rod. And now today it is for new rod. I am working for new rod. What is the change for new rod? What is the chain for new rod? So if you read the question, it is given for new rod, area of cross section is A upon 3. Area of cross section is A upon 3. So I am writing A upon 3 is the area of cross section for the new rod, as well as the new rod has Young modulus 2e. Young modulus is 2e. So I am writing Young modulus as 2e. So if you solve this number 3 and 2, then it becomes 3 upon 2 and it is 1 upon a e. And do you know this 1 upon a e is equal to 2 millimeter? So I can replace this 1 upon AE as 2 millimeter. And when you cancel out 2 with 2, then the answer becomes 3 millimeter. It means when you will apply a force from 0 Newton to 90 kilonewton, for the same force 0 Newton to 90 kilonewton, the compression in the new rod will be 3 millimeter. Compression in the new rod will be 3 millimeter. So I am drawing graph, and in this graph the initial rod length is 150, and for 3 millimeter compression final length will be 147. So I have marked 147 as a final length, and now I am joining 150 millimeter to 147 millimeter, and it is the graph for new rod. This is graph for new rod. This graph were given in the last class. It was old rod, and for old rod, when you apply force 0 to 90 kilonewton, when you apply force 0 to 90 kilonewton, the compression in the rod were 2 millimeter. The compression in the rod were 2 millimeter. This graph is given. And now today, the rod is replaced by a new rod, and the new rod having same length. So I have cancelled out length. The new rod area A upon 3, so I used area A upon 3. Young modulus 2e, so I used young modulus 2e. So by calculation 3 upon 2 becomes constant, and this 1 upon AE, actually this 1 upon AE is equal to 2 mm. And when you solve this number, so for the new rod it is 3 millimeter, so compression 3 millimeter, so 150 original length minus 3 millimeter compression, so final length becomes 147 millimeter. So I have drawn this graph, and this calculation I believe it is very difficult. That is why I did not explain this question in the last class, but right now we have done. And the same kind question I have another, that is question number 4. 4 last part, but a 4 last part again. Again the 4 last part, you are given a wire. In this question the term is wire, okay, and you are given a graph. This is a graph, and this graph is for old wire. And today the new wire is used, and for this new wire what is remain same, so that I can cut new for I can cut same kato. So read the question. So read the question. What is the what will remain same? So sketch the variation with the extension x. It means today extension is same. Extension is same. Okay. So I'm writing Young modulus is equals to force per unit area, extension per unit length. In this question, extension is expressed by x, and the question is sketch variation with extension x 0 to 0.8 millimeter. For old wire, extension was 0.08 millimeter, and for new wire again extension is 0.80 millimeter. So extension remaining same. So I am cancelling out extension as well as note down any other quantity which will remain constant. The wire is replaced by new wire of same material. Material is same. Abeta Nandini, if the material of the two wires is same, then which symbol I should cut? F, L, A, E. Which symbol should I cut for the same material? When the material is same, then which physical quantity will remain same in this formula? Nandini? So the answer is, हाँ बेटा, same material. Material value depends upon Young modulus. Young modulus value, the value of Young modulus depends upon material nature. Okay, beta. The value of Young modulus depends upon nature of material. If the material wire remains same, if material wire remains same, it means Young modulus will remain same. So I have cut two physical quantities as some same ko kato. Young modulus due to same material, extension is same. Okay. And now we have to draw graph of force and extension. And as you see, if extension is same, so I am making force as a subject. So force is equals to A upon L. Force equal to A upon L. And for the old wire, force is 4 Newton. For the old wire, force is 4 Newton. So I am writing force is 4 Newton for old wire. When 4 Newton force is applied on the old wire, extension in the wire was 0 to 0.8 millimeter. And now we are working for the new wire. And for the new wire, but Nandini, as you gave me wrong answer, so I am asking you. हाँ बेटा, F is equals to A upon L. And in this question, remember, area is not given. In this question, you are given diameter. And you know that area is equals to pi d square upon 4. And pi is constant, force is constant. So I should write d square upon L. After force, I should write d square upon L. In this question, you are not given area, you are given diameter. You are given diameter. So I made equation of force in terms of d square upon L. I made equation of force in terms of d square upon L. And this d square upon L is equal to 4 Newton. हाँ बेटा, now Nandini, I am asking you beta, for new wire, what is changed? Beta, what is diameter for the new wire? Beta, read the question. Read the question, beta. What is the diameter of new wire? Diameter of new wire is twice the diameter of old wire. Okay. Diameter of new wire is twice the diameter of old wire. Number one. Number two, the diameter length is twice. Diameter length is twice. So length is doubled as well as diameter is doubled. And now if you simplify, it becomes 4d square upon 12. And if you simplify this 2 1 the 2, 2 to the 4, it is 2. And this d square upon L equal to 4 Newton. So if I replace d square upon L by 4 Newton, then 4 2s are 8. 4 2s are 8. It means when the new wire is used for the new wire extension 0 to 0.8 millimeter, force value will be 8 Newton. Force value will be 8 Newton. So I am going to draw the graph from 0 Newton to 8 Newton. because this is 8 Newton. So 8 Newton will be the force. 8 Newton will be the force for the same extension. Extension is from 0 to 0.8 millimeter. For the same extension, that is 0.8 millimeter. For the same extension, 0.8 millimeter, the extension in the wire, the extension in the low new wire, 0 to 0.8 millimeter, the required force will be 8 Newton. The required force will be 8 Newton. And this 8 Newton force is calculated by method same co kato. When the quantities are same, then same quantities should be cancel out, and cancel out means kato. So I have cut same co-kato quantities, that is extension, Young modulus, pi and 4, and the remaining equation becomes very simple. And I have used this the same method in current electricity chapter. I have used the same method in wave chapter, because when you have a very long equation, then we should simplify the equation by using same co-kato. Okay, beta. So we have done these two questions, and I think you have understood, as well as I will give you its video. So I hope if you did not understand, then you should watch video. And now I am going to explain more question on the same Kokado, but I am starting paper one questions. And you know that paper one questions are very, very difficult. And if you solve paper one question, then you can solve any kind of question. So we are solving paper one questions. Let's start. And I'm starting with the question in which I will use same Kato method. Ha beta. Now this is the question on your screen, beta. This is question on your screen. And if you can note down its variant, it is June 18, paper 11, and it is question number 18. Okay. And what is the question? Sir, question is the diameter of a wire is capital D, the length of wire is capital L, and it is clamped between two blocks. Okay, it is clamped or suspended by two blocks, and a load is hung. And a load is hung. Okay, so you are given diameter, you are given length, and you are given extension. Extension is x. Extension is x. Okay, so if I ask you to write Young modulus equation, sir, Young modulus equation is E is equals to force per unit area, but I am writing pi d square upon 4 instead of area. Extension per unit length. It is whole equation. Abda Anjum, can you help me? Which quantities should I cut for second wire? Abda, which quantities should I cut for second wire? Abda, second wire having same material. Abda, if the second wire is made of same material, then which? Yes. If it is same material, then I should cut Young modulus. Number one. Number two, same load is hung. Same load is applied. If the same load is applied, beta, what should I cut? What should I cut? Force. Yes, I should cut force. As well as pi is a constant, force is constant, 4 is constant. Okay, and in this question we have to calculate extension. So I am making x as a subject, so x equal to L upon d square, and it is for first wire. It is for first wire. This equation is for first wire. And now I am working for second wire. Second wire, beta. Now I am working for second wire. Beta Anjum, can you help me to calculate extension for the second wire, and you know that extension equation is length upon d square. Hi, but Anjum, can you tell me what is the change for the new wire? What is diameter and what is the length? Yes, length is increased by 3, diameter is increased by 2. Yes, you are right. And we are calculating new extension. So this 3 remains constant, 2 square 4 remains constant, and this L upon D square. And what is L upon D square? Sir, this L upon D square equal to X. This L upon D square equal to X. So new extension will be 3 upon 4 is a constant number, and this L square upon D square is replaced by X. So new extension will be 3 upon 4x. And if new extension is 3 upon 4x, but Anjum, then what is the answer? It is answer B. Okay, but the answer is B. So today I am solving only questions about same, co, kato. And how do we identify, sir, if this is a question of same co-kato? So, beta, whenever you have to calculate ratio, or it is given that a wire is replaced by new wire, the wire is replaced by second wire, it means you are given some data for first wire, and now you are going to calculate something for the second wire. So, check which quantity will remain same, and any physical quantity which remains same, then you should cancel out the same quantity. And after cancelling out same quantity, the equation is converted into very simplified form. Okay, and now this question is solved, totally solved by Anjum. Hi beta Afra, can you help me to solve another question, Afra? Beta, can you switch on your microphone? Okay. Okay, I am solving a new question. This is this question. Okay. This is question number 19, beta. This is question number 19, November 17, paper 12. Okay. And in this question, you have to calculate a ratio of stress. Ha, beta, Afra, if you are going to calculate a ratio of two same quantities, then which method you should use? Same ko kato. Beta, Afra, if you are calculating ratio of stress, then which method you should use? Yes, yes. And we are going to calculate stress ratio. So first I am writing the formula of stress. You know that stress is equals to force per unit area. And in this question, area is in the form of diameter. So I am writing pi d square upon 4. However, which quantities will be same for wire X and for wire Y? So you will say, huh, beta, which quantities are constant in this equation and which quantities should I cut? But Afra, help me. Pi and 4, number 1. Number 2, same force, same force is being applied. Same force is being applied on the this object. Okay, so force should also cut. Okay, and now the equation becomes very simple. Stress is equals to 1 upon d square. Stress is equals to 1 upon d square. So if you are calculating stress in y divided by stress of x, then I will use square of diameter. I will use square of diameter, but here I will write x and here I will write y. Why? Because, sir, stress is inversely proportional with diameter. So for y stress, diameter of y. For x stress, it is diameter of x. And now, beta Afra, can you help me? What is the diameter in x and what is the diameter in y? Sir, in y, this is diameter. In x, it is diameter. So x diameter is 2d and y diameter is d. Then what is the answer, beta Afra? Afra, beta, what is the answer? D cancel out with D, and square of 2 it becomes 4. D cancel out with D, and square of 2 becomes 4. So stress of Y dividing by stress of X, and it is equal to 4. And we have solved this question by method same co kato. When you have to calculate ratio, when you have to calculate ratio, then I use same co kato method. Okay, beta? And now the next question should be solved by Nani if her microphone is working. Hi, beta Nani, can you solve next question with me? Okay, beta. So this is another question. It is March 2017 question. March 2017 question. And in this question, we are calculating a ratio of tension, ratio of force. And if you are calculating a ratio, then you must use same Kokato method. And in this question, read the question. Sir, two wires X and Y are made of different metals. Young modulus is itna itna. The diameter itna itna. The wires are extended with same strain. Strain is same. Okay. Strain is same. Okay. So I am writing young modulus is equals to stress over strain. हाँ beta. Same strain means what should I do beta Anandi? If the strain is same, then what should I do? In question you are given same strain, and when we are solving same Kokato, then I should cut strain. So I have cut strain, and now young modulus equal to stress, and you know that for stress is force per unit area. But in this question, again, you are given diameter. And if you are given diameter, then I should write pi d square upon 4. And in this equation, pi d square upon 4, again pi and 4 same co-kato. So equation becomes young modulus equal to F upon d square. And you know that tension is a force. However, tension is a force. It means we have to calculate force. So force is equals to E d square. Force is equals to E d square. So we have converted the equation of Young modulus into a very easy form, and the easy form is F equal to E d square. Young modulus is equals to F is equals to E d square. Hi beta Nandini, I have converted this equation into very easy form. Is it clear beta? Okay, and now we are calculating tension in wire X divided by tension in wire Y. So tension is a force. So force is equals to Young modulus of X diameter of X divided by tension in Y equal to Young modulus of Y and diameter of Y. And now I am waiting. Hi beta, what should be the answer? Nandi, put the values and give me the answer beta. Young modulus of X is twice of Y. Young modulus of X is twice of Young modulus of Y. Young modulus of X equals to twice of Young modulus of Y. Number one. Number two, diameter of X, diameter of X is half of diameter of Y. But Nandi, I am waiting for your answer. Young modulus of X is twice of Young modulus of Y. Diameter of X is half of Diameter of I. Yes. And if we solve, cancel out these number, and 1 upon 2 square, it becomes 1 upon 4. 2 multiply 1 upon 4, it becomes 1 upon 2. So Nanni's answer is right. The answer is B. The answer is B. ठीक है बेटा, the answer is B. अच्छा जी. And now I am going to explain you the most difficult question of this unit. That is, it is not very difficult. It is a normal difficulty level. The toughest question is this of crane question. But this is very difficult question. Okay, and inshallah at the end of the class we will solve that question. But before that question, we should solve this question. Ha beta. In this question, beta Anjum, now it is your turn. Anjum beta, you have to calculate extension divided by extension. It means you are going to calculate ratio of extension. And if you are calculating ratio of extension, then which method should we use? Which method should we use, Anjum? If we are calculating ratio, then we should use same co-kato method. So first I have written the whole formula. First I have written the whole formula. And now read the question carefully. Ha beta, can you tell me which physical quantities should I cut from the equation? Beta Anjum, read the question. Young modulus is twice length 50 centimeter, diameter 2 millimeter. The combination wire is stretched by a wire added to its end. Both the wire and the steel obey Hooke's law. What is the extension? हाँ बेटा, which quantity can I cancel out? जी बेटा अंजू, कोई भी कैंसिल नहीं हो रहा. हाँ तो नहीं, यंग मॉड्यूलस तो नहीं कट रहा, मैंने मान लिया. लेंथ दोनों की सेम है. नहीं सर, कॉपर की लेंथ 50 सेंटीमीटर है, और हाँ स्टील की रॉड भी 650 सेंटीमीटर है. सो वी कैन कैंसिल आउट लेंथ, we can cancel out pi, we can cancel out 4, and the same load is hung. हाँ बेटा, the load is same for steel wire, the load is same for copper wire. So we can cancel out F. So we can cancel out F, and we have to calculate extension ratio. So make small e as a subject. Then small e is equal to 1 upon d square into E. Small e is equal to 1 upon d square E. It is the simplified equation after same को काटो. हाँ बेटा अंजुम, same load is hung, force is same because one load is hung for the two wires. The first wire is copper wire, the other wire is steel wire. So the load is same. So I have cut force. And now you can solve extension of steel wire, and you can solve their ratio. So I am writing, and I am writing in this way. Sir, extension is inversely proportional. So for steel wire, I should diameter of steel. I should write Young modulus of steel in denominator, and in numerator for copper, I should write diameter of copper, and I should write Young modulus of copper. I would note down. I have written the equation of extension in form of diameter and Young modulus. I have written the equation of extension in the form of diameter and Young modulus. And now put the values. Now beta put the values. Sir, Young modulus of steel is twice of copper. Okay. For steel, it is 2 times of copper. So it is the relation for Young modulus. And now for diameter. Sir, copper diameter is 2 millimeter. Copper diameter is 2 millimeter and steel diameter is 1 millimeter. So if you solve it, beta, what is the answer, beta, Anju? Beta, Anju, what is the answer? Yes, the answer will be 2. 2 and 2 cancel out. So the final answer is B. Okay, beta. So in this way, we have solved many questions on same Kokato, and the toughest question I am going to solve. But this question number 35 is very simple. This 35 question is very simple. In this question 35, in this question 35, young modulus of steel, the young modulus of steel is E. Young modulus of steel is E. In another experiment, the wire of same steel. In first experiment, steel wire. In the second experiment, the same steel. Remember, if material is same, then remember young modulus will remain same. And they are asking what is young modulus. Habita Nandi, can you give me the answer? What will be the answer of 35 question, beta? In first experiment, we used steel wire whose young modulus is E. And in another experiment, the same steel wire is used, but length is half, diameter is half, and it has no significance. Length is half or double, diameter is half or double. The main thing is the value of young modulus depends upon material. If in first experiment material is steel, in the second experiment material is steel, so young modulus will also remain same, and the young modulus will be E. ठीक है बेटा? अगर मटेरियल नहीं बदला तो यंग मॉडुलस विल रिमेन सेम. कोई फर्क नहीं पड़ता कि लेंथ कितनी बदली, डायमीटर कितना बदला. The main thing is if the material remains same, then the value of young modulus will also remain same. Then the value of the value of young modulus will remain same. Okay. And now I am going to solve the most difficult question of this chapter, of this crane question. Okay. And this the same question is repeated. And before starting crane question, I am teaching you some extra knowledge. Then we will solve that question. But the question is consider. Abda Anjum, can you help me? Consider. Balki, I think this question should be solved by Nandini because Nandini is a mathematics student. Abda Nandini, this is a cube. Consider its length is 10 meter, breadth is 10 meter, height is 10 meter. Okay, but it is a cube. So its all dimensions are same. Length, breadth, and height. All dimensions are same. And consider its weight. Weight is W is equals to mg. You are not given mass, so you can write mass is equals to density into volume. And what is volume? Sir, volume is length into breadth into height. into g. How about note down this equation, beta? Note down this equation, then we will try to solve that question. Weight of a cube, weight is equals to mg, mass not given, so mass is replaced by density into volume, volume not given, so volume is length into breadth into height. This is the original block. This is the original block. And now we are making its model. And the model is made of same material. Material is same, but all dimensions are reduced by 110. All dimensions are reduced by 110. If all dimensions are reduced by 110, then obviously length, breadth, height will be reduced to 1 meter, 1 meter, 1 meter. And now my question is, what will be its weight? You know that weight is equals to mg. Mass is equals to density into volume. Volume will be change. Volume will be change. Density is same. And you know that if density is same, so we can cut density, we can cut gravity. The main thing is volume. How about what will be volume, sir? Volume will be length into breadth into height. So new volume will be 1 upon 1000 time original volume. So new weight will be 1 upon 1000. Okay. So my what is my question? The question is, sir, we are given an original block, and when we are making another block of same material, but all the dimensions are reduced to 1/10. If all dimensions are reduced to 1 upon 10th, then its weight and volume will be reduced by 1 upon 1000. Its weight will be reduced by 1 upon 1000. If all dimensions are reduced by 1 upon 10, then weight of the model will reduce by 1 upon 1000. हाँ बेटा, is it clear or not बेटा? Okay बेटा, okay. अच्छा जी. Another practice I am explaining you, then we will solve that question. हाँ बेटा, have you noted? हाँ बेटा, have you noted this calculation? Okay बेटा, and if you have noted this calculation, then I am explaining another explanation. The explanation is, consider this is a wire of original crane, and you know that this wire will be very thick wire. This wire will be thick wire because it lifts very heavy load. So crane hanging wire is very thick wire, and consider its diameter is d. Its diameter is d. So if I ask you what is the area of this original wire, what is the area of this original wire, then you will say, sir, area is equals to pi d square upon 4. And now I am making another wire whose all dimensions are reduced 1 upon 10. And if all dimensions are reduced by 1 upon 10, then obviously diameter will be reduced by d upon 10. It is model. It is a model wire having dimension 1 upon 10. So if I ask you what will be its area, then you know that pi is a constant, force is a constant. The new thing is d upon 10 square. Diameter is reduced d upon 10. So d square remains same and the area will reduce by 1 upon 100. 10 square, 10 square means 10 square means area is reduced by 1 upon 100. So in crane, there are two objects in our question. The first one for the wire, the dimension of wires are reduced by 1 upon 10, as well as that block, and block is also reduced by 1 upon 10. So the weight of block reduced by 1 upon 1000 and the area of wire is reduced by 1 upon 100. I want to note down this calculation, then we are going to solve that question. I want to have you noted. Okay, okay, beta. And now I am trying to solve this question. This is a very difficult question, but we are trying to solve this question. Okay. So what is the question? So question is, this is original crane, and now the question is, a model of crane is made. A model is made of the crane. A model is made. And in the model, the material used is same. Material used same. Same material used. However, when material is same, it means young modulus will be same. Okay. If material is same, then young modulus will be same. And the main thing is the cable and the load. This is the cable, it is the load. The question is, the model is 1/10 of original size. Model load, model block, model cable, all the dimensions are 1/10 of full size. 1/10 of full size. And they are asking to calculate stress in full size crane divided by stress in model crane. Okay, so we are going to calculate. What is the formula of stress? Sir, formula of stress is force per unit area. And this force per unit area for full size crane. This is force upon area of full size crane. But in denominator, there is model crane. And if it is model crane, which is 1/10, which is 1/10. हाँ बेटा Afra, can you tell me, F is the weight of load. F is the weight of load. If the load dimension reduced to 1/10, if the load dimension is reduced to 1/10, it is the original load. It is the original load, and when we made its model, then all dimensions are reduced to 1 upon 10. When dimension reduced to 1 upon 10, then obviously the model block will be very small size. And if it is very small size, beta, how much weight will be reduced? The model load is reduced to 1/10 of its original size. हाँ बेटा Afra, when we made a model whose dimensions are reduced by 1 upon 10, then how much weight of the same block will be reduced? हाँ बेटा Afra, How much weight of model will be reduced? How much weight of model will be reduced? हाँ बेटा, how much weight of model will be reduced? Dimension is 1 by 10. Dimension length reduced by 1 upon 10. Breadth reduced to 1 upon 10. Height reduced to 1 upon 10. Then obviously volume reduced by 1 upon 1000. 10 multiply 10 multiply 10. Volume reduced to 1 upon 1000. And if volume reduced to 1 upon 1000, then the weight of the block will also reduce by 1 upon 1000. So the weight, that is force is reduced by 1 upon 1000. Okay, but I have explained you earlier, when the model block is reduced 1 upon 10, then its weight reduced by 1 upon 1000. And in the same way, what about area? Area of cable. Area of cable. So I have taught you area is pi d square upon 4, pi constant, force constant. Actually, diameter reduced by 1 upon 10. And if diameter reduced 1 upon 10, then area reduced 1 upon 100. So area reduced by 1 upon 100. Okay, but note down this calculation. Area reduced by 1 upon 100, force reduced by 1 upon 1000. And if you simplify these numbers, then result becomes 1 upon 10, and the final result will be only 10. If you solve these numbers, then the final result will be only 10. So the right answer is C. So the right answer is C. So, but I am giving you its recording, and as well as I said, deformation MCQs are very difficult. So we have explained, and I am stopping my recording.